Let's go through the code 652. Find the duplicate subtrees. For this question, it gives us a tree root. And let's find all of the subtree which are duplicate, has a duplicate. For example, this 2 and 4 and 2 and 4. You will see um, there are two, so this one and this one appears twice. And also we'll see this 4 appears 3 times. So we'll return those kind of trees like 2, 4, this subtree and also this subtree, creating a list of tree nodes. So for this question, actually, what we can think about is that we can create a map, and then for every tree, we should use some kind of identifier. Possibly, we can use that string to to um, to identify a tree, and also we need an integer as count, and we also need an result, right? Um, list of tree node as a result. So we do DFS when um when it's so for DFS, this kind of DFS, we return the serialization of the tree. So what we're thinking about is that we can, for example, let's have a list of tree node, and the result equals new array list, and we need to have string in integer as count, right? Count map equals new hash map. And what we do is that we DFS, for this DFS, during the DFS, what it retain is the serialization of this tree. So we're going to have root count result, and in the end, just return result, right? So we have private string DFS. So this will be tree node, and we need to have this string integer to be counts, and also list of tree node as the result. So what we do is that if this tree node equals none, right, we just serialize this one, return empty upon. Then we can have string key equals um, node dot value. And we can have this one as to add an comma separate, right? We can also have an brackets, for example, this kind of brackets. Mm, brackets here, right? So we can have a DFS node dot left points in the result, and DFS node dot right points the result. So what we do is that um, so we'll see we can have this count map, right? Counts merge key one integer to sum, yeah. So what we do is that if this counts get key equals 2, right? If this one get equals 2, then we have a result should add this node. And in the end, just return this key. So this will be the basic concept. But doing like this, there is some kind of issue. The key is going to get bigger and bigger. Will be a very long string, right? And of course, you can add brackets after that. Um, it's going to be a very long string, and in this case, the serialization will be very efficient. So we can use a map actually to store those kind of keys to map it as an ID, right? So that instead we have this kind of long string here. We just put an ID here, right? So what we can optimize is that we can have ID key map, ID map integer or the IDs equals new hash, and um, we can put this one here, right, as keys IDs, and let this DFS just return ID int. So the thing is that if this um, let's have this one as a one parameter. So if this is null, right, this ID is just 0. So actually, we don't need these brackets. So we'll see. This is key. So we'll see if this appears. Um, that's the second time we need to add that, right? But else we'll see if it appears the first time, then we're going to have for example, int ID equals key ID dot size part one, right? Just we'll put a new entry to the ID map. So we'll have key IDs, put key ID, right? So in this case, um, it will also return key IDs get, right? In this case, this DFS is going to return an integer, right? So comparing to the previous one, every time the key will be very small, right? Just it will be, for example, the key originally it may have a lot of things like for example, one, three or whatever, those kind of things, right? And now what we want is that the key is always, for example, some kind of number one, two, three, right? And if it doesn't exist in our key ID map, then it add a new one. So the key is always get very slim in this way, and it will be much efficient because we don't have a very big string. Doing like this, the time complexity will be O n, and the space will also be O n. We can also have a Python code for this. So we're going to have result in the count and key ID equals this. This. So we can have a define a DFS node. This will be optional tree node. This one just return this node's ID. So what would be set if node is none, just return 0. So we're going to have a key equals uh, let's compose this node dot value and DFS node to the left and DFS node right. So we're going to have a count to the plus equal to 1. So we'll see if count key equals 2, right? That means the first time it appears twice. So it does have result append with can node. Else, else, else if right, count key equals 1, right? Then we're going to have key ID. Let's call key IDs. Will be much better. Key equals length key IDs plus 1, right? And for this DFS, we return key IDs key. And for our main function, we just DFS root. And in the end, just a return result. The count key plus equal to 1. What's probably key plus that has